Hello, everybody. This is Miss Eisencraft, and I'm here with a Lesson 5 recap. So, Unit 4, Lesson 5 recap. So, I'm just going to go from the summary page. Your teacher probably worked through a Desmos with you, or maybe you did it independently, going through a couple of the big ideas in Lesson 5. So, the big idea is we're still talking about how functions can be defined by rules. And knowing that rule that defines a function can be very useful. So we've seen this before with equations. We just didn't always identify them as functions. But when you know how x and y are related, you relate them through an equation. Same thing with a function. Knowing the rule that defines a function can be very helpful. Okay, so if you know how they're connected, so if we have the rule f of x equals 5 times x plus 2, if that defines f, then we can find f of whatever for that function, meaning we know what the machine is doing, so we can plug anything in there and predict or know what it's going to make. And one way to really keep track of that is a table of values. So they do that over here, and I just wanted to add a third. So let's take this function called f, and let's add a process column, okay? Here's the process column. So we're going to take 5 times x plus 2. We'll do that calculation, and then the output we're going to call f of x, formerly known as y, right? Same thing. So when we plug a 0 in to the machine is going 5 times the sum of 0 plus 2, and then spitting out the answer. So 0 plus 2 is 2, 5 times 2 is 10. And that's where that connection is coming from, because we know the rule. We plug a 1 in. It is taking 5 times the sum of 1 plus 2. So 5 times 3 is 15. So oftentimes we hide this process column, or we don't show it, right? We just have like a T-chart. So that third column really is helpful sometimes in either figuring out the rule or trying to figure out where did this come from, or seeing the pattern. All right, so then we have 5 times 2 plus 2. So 5 times 4 is 20. Okay, we'll do one more. 5 times 3 plus 2. 5 times 5 is 25. You can also skip. Now that we know the rule, we don't have to go in order. Okay? A lot of times kids like to go in order because they like to, especially with linear functions, it'll start counting by a certain number, and that's helpful. But if we jump to something like, I don't know, let's say 100. Finding f of 100, this rule, we just go 5 times 100 plus 2. Might be a little bit annoying to do the math, okay? But we would get, how about 510? Sounds good to me. Okay. So, and oftentimes sometimes they won't tell you the rule, or they'll ask you to write it out, and they'll put the variable here. And as you can see, if we don't know what x is, we just put it here. Say, well, once we do know what x is, it goes there, and then we'll get 5 times x plus 2, whatever that is. Okay. If you are going to look at a graph, what's nice to know in a graph is that you can see this also. The table, the input and outputs are the x and y's of the graph. So we used a 3-column process table before, but you could do it in Desmos and say, okay, when x is 0, oh, y is 10. There it is. When x is 1, they're the ordered pairs. Y is 15. When x is 2, y is 20. So you could do, and you can even go all the way to, okay, when x is, okay, my graph doesn't go that, my scale doesn't go that far, but let's say we wanted to skip all the way to 16. Let's see what it calculates to. Okay, so let's go back. It is also not so easy, but not that bad. You also can sometimes know what the will be given the output, and then it will ask you what the input is. So maybe this is where they gave you x and asked for f of x. So they gave you the input and asked for the output. Okay. So what if they tell you instead, well, f of x equals 60. What must x be to make that true? Oh my gosh, I'm writing. You can't see. Sorry. Okay. So same rule, same thing here. So let's identify. So f of x, we've already identified that rule to be 5 times x plus 2. Okay. We know it equals 60. Okay. We could probably work through this table and keep working until we find out what it is. But we can also use good old algebra. Okay. We just need to figure out, we can do our work backwards and do inverse operations to figure this out. Okay. There's multiple ways to do it, but this is probably one of the most efficient. Okay, so you could distribute. I know you guys love distributing, but also when the 5 is out front here, especially if it divides into this number, it's often easiest to divide by 5 to start solving for that x. So 5 times something has to equal 60. Well, this something has to be whatever this division problem is. 60 divided by 5 is 12. Now let's just solve for x by doing the opposite operation. X has to equal 10. So what we just figured out is we were basically given over here in our table, we were given this number, and it was asking us to try to go backwards. And we had to use algebra, like inverse operation. You could also go to your graph and say, okay, if f of x is 60, you could go over here to 60 and go, it looks like it's 10, right? And let's make sure you can go out of order. So many kids don't think you can go out of order on a table. The table is really related left to right. We often write it chronologically, but we are looking at how the left is going in and it's making the value on the right. So if they give you x, is you plug it into the rule, you get f of x. And oftentimes when they give you f of x, you're working backwards, knowing the rule using algebra. All right. Also, don't forget that a graph can be helpful, right? If they give you input, they're giving you the x value, you go up, see what your y value is, that's the output. If they give you the answer, right, or f of x or the output, you could go on your y-axis or your output axis, like they did here with the 60, go over and see what the input is by dragging down. All right, hope that helped.